Today we want to learn something else, something new, and what we want to learn is how we can compare the microcontrollers, the microprocessors to the uh, uh, processors in the laptops and in the PCs that we have at home. There is no much difference. Yes, you can think that they are different, but they are not. With me, I have here a laptop. That this is my laptop. You can see a laptop. I've opened the back so that we can see the motherboard. Here we have the motherboard with us. You can see every component. It's a small motherboard, not big, but very powerful, and a 12th generation laptop. So we want to compare this to these ones, the microcontrollers that are in the small boards like the Arduino boards and the ESP. Another one is these ones. So we want to see how this compares to the motherboard for the laptop. So a laptop and a microcontroller, they're all computers. They're all computers. They process uh, data to give you an information. So we want to compare them and see how they compare and what is same in each and what is different between a processor in the laptop or PC and this processor. So all those have the same functionality. One, they have the memory, they have the processors, they have the storage, that is, and they have the power control I see in them. So because they use power, they will have power management IC or uh, transistors in them to manage for them power. Then they will have memory to it's like a working space for the microprocessors to remember what it's working on and to store uh, data temporarily before displaying them as information or before storing them. Then we have the storage memory. The storage memories as they can store data permanently, and in both microcontrollers, microprocessors have some amount of memory, some have less, some have uh, significant amount of memory space in them. And then we have the laptop motherboard. They also have bigger memory space. So this microcontroller here is less powerful than the microprocessor in the laptop. So the difference comes in the power of the processor. How much information can it, how much data can it process in a given time? So this one is like a child to this microprocessor. They both have different architecture. Architecture defines how they are made and how many information they can process and at what speed they can process and which components are involved in making that data processing to be accomplished. So they are both computers, but computers with different capabilities, with different components. Some have abundant resources, some have less resources. So both the laptops and the microcontrollers, laptop motherboard and the microcontrollers like the Arduino microcontrollers, both of them are both of them have what we call the software. For a computer to work, there must be hardware and the software. So the software in Arduino or the microcontrollers, the ESP32 and all those, use what we call firmware. Uh, the processors in the laptop, like the Intel, the AMD processors, they use what we call operating system. and the operating system does not necessarily operate or control the hardware directly. So a laptop has much more complicated software. They have different softwares. We have the system software, we have the operating software, we have the firmware. That the firmware in these laptops, we refer it as the BIOS. So the BIOS is what deal with the components directly. Let's say if I want to control the fan, the BIOS will do that in collaboration with the operating system. It will control the components. So BIOS must be there for the operating system to be installed on a laptop. So without BIOS, this laptop cannot be on. The BIOS also checks all the components. It knows where the components are located and which pins are connected. Remember, we have what we call GPIO pins and the communication channels for these microcontrollers and microprocessors. For the laptop, they have also the GPIO pins connected to each and every component or IC dealing with different things. For example, we have an IC for power management. There is a way they communicate with the processor through the pins. We have the UART I2C for the microcontrollers and some other pins. They are just ways on which they communicate with the microprocessor. In laptop, we have the USB, we have the PCI slots, we have the audio communication channels. So it depends with the channel. It depends with what you want to control. There are different channels for different functions. They are for audio, they are for display, they are for fan, there is for everything. So microprocessors works with different ICs. They are like groups of components that does specific task. For example, if I can say there is an IC for power management, it ensures that power is flowing according to the to each and every component depending on the requirement, power requirement for that IC. Not all IC use the same power. Some use 3 volts, 3.3, some use 1.8 like the processors, or 0 point something volts. But the current also is different. So you might find a device using different current, different voltages. So the power IC knows each and every component's power specifications, then deliver those power to the correct amount of voltage and current to those specific IC. And then it protects also the microprocessors from overcurrent, overvoltage, and all those mistakes, power mistakes. So that is power management. In this, we have some MOSFETs like this. Therefore, you can find buck converters or boost converters in this to control the power getting to the main controller, the microcontroller here, to prevent them from burning or overcurrent or over voltage, over supply of voltage. So we have those. The microcontroller does not have a lot of things in them, so they are few components, but they have the same idea. They have power management. They have what we call oscillations. These are circuitry that controls the speed and the timing of how the processors work, at the speed at which the processors work, the timing, when to stop, when to start another process, like that. So it's the same, but in this, it is summarized. It's very few components, but in this laptop we have different. We have power management, like I've said. We have audio IC. We have the RAM section, the storage section. We have the fan for cooling. Then we have Wi-Fi and Bluetooth connectivity. Then we have what we call VRMs for power management. They help in controlling the power on the motherboard going to specific more so the IC, the processor. It has its own VRM. The VRMs manage power. The VRMs include the IC for power, for switching, power switching. Then we have the inductors, capacitors to ensure there is stable supply of power to those specific circuitry, like the processors. Then we have the display management. We have what we call the graphics card. In the latest computers, some have the dedicated graphic processors and graphics card, and some have integrated graphics card in them. So in one CPU slot, the core, we have also graphics card integrated into it. So it's one chip. So that chip contains both the CPU and the graphics processor. So in the microcontrollers, we don't have the graphic processors, but we use different channels, communication channels, to display information through the displays, the different displays. We have the OLED, we have the LCD, we have every display. So there are different communication channels for this, and as well as for the laptops. So these things also have the cooling, thermal dissipation. We have the fan. The same for the microprocessors and the microcontrollers, like the Raspberry Pi. They have what we call the heat sinks. Sometimes you can integrate heat sinks. For the processors, that does a lot of work, and they work at a very high speed. There is a lot of heat generated, and they need to be cooled. So if the heat dissipation is not taken care of, the microprocessors might be destroyed due to overheating. So we don't need overheating on these processors. For this, we have an heatsink. We have heatsink, then to the fan, and then the fan will just blow cold air on the heatsink to cool it down. So the heat is transferred from the processor, which is under this heatsink, to this side of the fan, and then it is blown out. The hot air goes out, then the in air come in through other vents, and then we have several things. So both microcontroller and the laptop motherboard, or the PCs, have what we call the memory. And memory, we have two types of memory. We have the RAM and the storage memory. So solid state drives, these ones are for storage, for the modern laptops. And we have RAM. So these are random access memory. They're for temporary storage of data that are being processed, or the information to be displayed on the motherboard. So without this, the computer will not work. And on the microprocessors, we also have all those integrated in this one chip. So this chip contains the processors and contains the RAM, and the RAM in the microcontrollers, we call them the SRAM. So we have flash memory in here and the RAM. So the RAM in this is very small in terms of kilobytes, but for this, these are in 8 GB, 16, 32, some go up to almost 96. So RAM for the laptops are very big, and they are able to handle a lot of processing, and they can hold a lot of data while doing processing. So this is the RAM for the laptop. Some have onboard RAM, like this one. We have 2, each is 8, which means this has a total of 16 GB RAM. And we have the SSD slot, where it's supposed to be plugged in somewhere here on at this end. It should be inside this, so it's plugged in here. And then we have some other components here. So on the laptop we have softwares like the BIOS, the operating system, then the application. Without the BIOS, you cannot install operating system. Without the operating system, you cannot install applications on the laptop. So BIOS must be good and working to ensure that the computer is powering on and is able to test each and every component it has that perform different functions to make it, or at least function. And then we add the operating system to help the computer to communicate properly with the user. The user must be able to communicate, or to communicate with the computer through the operating system. So within the operating system, there are several softwares that control different things. Those softwares, we call them the drivers. There are drivers for camera, there are drivers for the audio, there are drivers for the display, there are drivers for each and every functions in the laptop. So these drivers, without them, the specific components in the laptop, like the camera, the display, will have a problem. So you must install the drivers after installing the Windows. The Windows come with the default drivers, so with time they become outdated, you update them. So there is no too much difference between this motherboard and this motherboard. They all does the same thing, but one is can do a lot of things at the same time, while this one can do a few things. So this one uses the firmware directly, firmware to control the components directly. But these have to have at least the BIOS, the firmware, the operating system, and an application. So all those, that is the difference. And then they use different architectures. We have several architectures in the laptops. We have 64-bit architecture, we have ARM architecture, and 86 architecture, 32 architecture for older generation. So this one has the same functionality as this. The only difference is this has few resources and can run one firmware at the same time, but this can run several one firmware operating system with several applications in them, or several operating system in it. So it can multitask. It has a lot of resources like the RAM, the storage, and it uses a lot of power. So the power management in it is serious. With a lot of power, we need a lot of cooling. It has the cooling system like the fan and all, the heat sink and all those. There are those that use liquid cooling. So that's the difference between this and this.